Okay, let's start explaining this assignment. So for the first question, consider the worst possible insertion order for 10 strings, each 2-character slot into a TST. What is the height of the tree after these insertions? So if we start with the worst possible insertion order, it would be something like ABC, BCD, DEF, and continue on. So for start, it would be like it would start with A, B, and C, which is a height of 2. And then for BCD, we move to the right of A and down 1. So be on the same level as the first ABC to be in that string. So the height of the tree will increase by 1. So it'd be from the height of 2 until the height of 3. So we just continue that pattern of plussing 1 for each new string added. And eventually we get a height of 11. And for question 2, consider the worst possible insertion order for 10 strings, each 3-character slot, into a binary search tree. What is the height of the tree after this insertion? The worst possible order for our binary search tree is just a tree where it only has a right child and no left child, or only left child, no right child. So you have just 10 nodes continuing on in one branch. And since then that would just be a height of 9 because there are 10 strings right here. So for this question, consider the following bounded left-leaning red-black tree containing 12 nodes. We don't care about the specific values of the elements, so nodes are blank. In these questions, we also asked about the corresponding 2-3 tree. Okay, so what is the height of the corresponding 2-3 tree? If we go back up, this is a red-black tree, and the 2-3 tree is where this node is in this node, and this node is in this node. So we will go from this is height of 1 to height of 2. So the answer is height of 2. And at least how many values you need to add to the corresponding 2-3 tree in order to cause a height increase. So since this node has 2, and this node doesn't exist, since you have it like this, and we draw this one to right here. So this node will have 3 children. We need to insert at least 3 nodes in order for these two to have another node down here, and in order for that to have a height increase. So we need to add 3 values in order for the corresponding 2-3 tree to cause a height increase. And at most, how many values can you add to the corresponding 2-3 tree without causing a height increase? That would be 14, because right here, let's see, right here, a 2-3 tree with 3 levels can store between 7 and 26 elements. We know there are 12 elements right here, and so adding 14 will reach the maximum 26 elements allowed for a 3-level 2-3 tree. And at least how many values do you need to add to left and right black tree in order to cause a height increase? That would just be 1 because you add it right here, 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 or here, or even here, and you will all just cause a height increase. Question 5. What happens when a new element of a value greater than all other elements added to this left linear right black tree? And the answer is that you will insert a red edge right leaf hanging off the rightmost branch represents the element. Then rotate left on a new left parent node. It will be right here because it is greater than this element, and it's greater than this element, and it will be greater than this element. That is the reason why it is on the rightmost. Yep, and that's it for this assignment. Thank you.